prove that 1 plus cos to the power 4x minus sine to the power 4x is identical to 2 cos squared x. So first thing to do is to decide which side to begin with. Should we start on the left-hand side and make that become the right-hand side, or vice versa? The left-hand side there, the 1 plus cos to the power 4 minus sine to the power 4, is much more complicated. There's much more things I can do with that. It's much easier to reduce the powers of 4 to make them become squared than the opposite way round. So I'm definitely going to start on the left-hand side. And a key thing that I notice about the left-hand side, let me just copy this down, is that I've got a difference of 2 squares. Now power 4 is an even power, so it's still a square. I can rewrite this if I just copy the 1 down at the beginning. Now the cos to the power 4 minus sine to the power 4, so I could rewrite this as cos squared x plus sine squared x times cos squared x minus sine squared x. Hopefully you can see that if I times those two together, I get this. If I times these two together, I get this. And the two terms in the middle would cancel each other out. So that's all good. And even better than this, I've got cos squared x plus sine squared x, and I know that that is just 1. So I've got 1 plus 1 times cos squared x minus sine squared x. So 1 plus 1 lot of cos squared is cos squared, 1 lot of sine squared is sine squared. And I need to rewrite this so it's only in terms of cos squared. So I need to replace this sine squared, which is fine because I know that sine squared is the same thing as 1 minus cos squared. So I'm going to rewrite this. I'll copy the 1 plus cos squared at the front, and that sine squared I'm replacing with 1 minus cos squared. I just need a bit more space here, so let me just move that up a little bit. So yeah, expanding those brackets, minus 1 plus cos squared, the minuses cancel out, and I get 2 cos squared, which is the right-hand side.